Welcome to Acids and Bases. Acid-base reactions are everywhere, even in your home or your kitchen. Let's see how. I just got some of this fun butterfly pea flower tea. Let's make some and see what happens. Look at that lovely teal color. Now, I like lemon in my tea, so I'm going to take a little bit of lemon juice and put that in here. Let's see what happens. Huh, look at that. I put lemon juice in here and it turned purple. What's going on? Well, what makes the lemon juice so tart is that it contains citric acid. So when I added lemon juice, I actually was adding acid. What's an acid? Well, as you might remember, in a water solution, like my tea, an acid is any type of molecule that contributes H+ ions to the solution, which forms the hydronium ion. Citric acid does that. So why does that change the color? Well, the color that you're seeing in this tea is due to the way that a particular molecule in the tea absorbs light. The form of the molecule changes with the acidity, with the availability of hydronium ion. Specifically, the molecule is a type of anthocyanin molecule. The anthocyanins have O atoms and OH groups, which we call hydroxyl groups, hanging off of them, dangling in space. If there's enough hydronium ion around, it can attack an O atom on the anthocyanin, changing it into a hydroxyl group. That changes the way that the molecule absorbs light. And that's what happens when I add citric acid from the lemon juice to the tea. The opposite of an acid is a base. A base contributes hydroxide ions, negatively charged OH ions, to solution. Those hydroxide ions want to grab an H+ ion, if they can find one, to form H2O. So you might ask, well, what would happen if I added a base to my purple tea? It's a good question. You might expect that it will rip an H+ ion off of one of those hydroxyl groups on the anthocyanin molecule, turning it into a dangling oxygen, and that this might change the color again in a different way. Let's find out. Now, we don't usually add bases to tea, but you have some common bases in your house. Many antacids, bleach, and ammonia-based window cleaners are all bases, but we aren't going to add bleach to our tea. But what we can add that you probably have in your kitchen that's actually safe to eat is baking soda, and it acts like a base. So let's add some of that. Let's take a spoonful of baking soda and add it to our tea. Fizzes a little as it dissolves, and once it's fully dissolved, wow, look at that. It's green. The color changed. And so now you know that one way that we can tell whether something is an acid or a base is by how it affects the color of a solution that contains a molecule like anthocyanin. We call molecules like anthocyanins indicators because they indicate something about the acidity of a solution. And now you also know that acids and bases aren't only in the chemistry lab, they're everywhere, even in your home, even in your tea.